All right, so the first thing we have is we have this chart up at the top. It kind of summarizes what we're going to do. So step one is we're always going to look for the greatest common factor first, okay? And then step two is we're going to look for a pattern. It says if we have three terms, it says move on to step three. And their step three says that you use this diamond and box methods, but we have not been doing that, right? So what we've been doing for those is when there's three terms, is we have been doing the two numbers that need to multiply to A times C. And then the same two numbers need to add up to B, right? So that's equivalent to what they're talking about using the diamond and box methods. Now in here where it says check for a pattern, so again, for three terms, you're going to look for this thing right here. Two numbers that multiply to A times C that add up to B. And then if it has two terms, you're going to look for the difference of squares. So difference of two squares. That was yesterday's lesson. And then I want to add in if it has four terms. So let's write that in here. So if you see four terms, I think there's only one on the homework. I'll make sure to review four terms with you guys before we take the test, because I think there's only one in today's assignment. And I'll make sure to review a couple with you either tomorrow or before the test on Friday. If it has four terms, you got to go back to, I think it was section 8.2. It was the second half of the notes from section 8-2. In fact, I could probably show you that real fast. If I show you that, that looks like, yeah, it was these right here. This was out of section, so really like number 9 right here. That was four terms. That's out of section 8.2, example 9. But again, I'll review that with you guys again. That's called factor by grouping. You can see that right there. So when there's four terms, you're going to look for a factor by grouping. But let me get back to the right page here. Okay, so we're going to write in this box, we're going to write four terms. So the pattern you're looking for is factor by grouping. And that's really it for the notes. Other than when you get your final answer, this fourth step down here, when you get your final answer, step 4, you got to look at your final answer and decide whether there's anything else you could do. So you do the problem, but you got to look at it carefully to decide if you can go further and factor it more with a different method. So let's look at 1 and 2 here. So 1, they want to know, is that factored completely? Well, what you have to do then is you have to look inside the parentheses here. Is there still a greatest common factor for 4 and 6?
Yeah.
What was it?
2.
Yeah, 2 is the largest number that divides evenly into both 4 and 6. So you're going to have to add a greatest common factor of 2. And then is there an x in both terms?
Yeah.
Yeah, what's the lowest power it appears to? Yep. So you're also going to factor out an x to the first. So the greatest common factor for what's inside those parentheses is 2x to the first power. And then you're going to kind of, to finish what's in those inside those parentheses, you're going to do like the distributive property backwards. So you're going to say 2x times what would give you 6x squared?
3x.
Yep, good, 3x. So that'd be a 3x. And then minus. And again, if you're having trouble with this step, what you can do is you can take this term right here, that 4x, or that negative 4x, and you can divide it by your greatest common factor, which is 2x. That's another way to think of it. But anyway, so 2x times what would give you a 4x? 2. Just a 2, right? And again, if you're not sure if you did that right, you just redistribute this thing. So if you did 2x, oops, I didn't want to circle that. If you did 2x times 3x, that'll give you the 6x squared. Then if you do 2x times negative 2, that'll give you the negative 4x. All right, but then don't forget, you still got to bring down the fact that you had a 3x in front of this thing right here, right? This part. So there's still a 3x in front of here. And those are multiplied together. So you would do 3x times 2x, which would give you 6x squared. And then that would be times the quantity 3x minus 2. So that would be the final answer on that one. So that original problem, they had factored out a common factor of 3x, but they didn't factor out the greatest common factor. So let's look at number 2. So it's kind of like you're trying to break this down. Remember we did this with numbers way back when we started this chapter? We broke it down into prime factorization, where that bottom line when we factored the numbers were all prime numbers. Well, that's kind of what we're doing here. Is this one right here, is that prime? Can you factor x squared plus 1? What do you think? Yes or no? No, you can't. You can't factor that. That's prime. And then x minus 4, is that prime? Yeah, so that one's done. So that one's fully factored. I'll just write, the question was, is it completely factored? So number 2 is yes. That is completely factored. But let me go off on the side and I'll show you how like this could be different. So what we have right now, let me see what it was again, x squared plus, all right. So off on the side over here, I want to show you this. So right now we had x squared plus 1, right? Times, what was that, x minus 4? And we said that was prime, right? Now watch how this changes. All I have to do, if I changed this addition right here, if I change that to a subtraction, that's not prime anymore. That is the difference of 2 squares now. Because that would be x squared minus 1 squared. And then does anybody remember from yesterday, what does that break down into then? You're using, yeah, you're using this thing. Remember, if you have a squared minus b squared, that's the difference of 2 squares. That's going to factor into a plus b times the quantity a minus b. So that's what you're using. So that thing is going to break down into x plus 1 times the quantity x minus 1. And then you would have to bring down that x minus 4. But just for a second, let's pretend that this one x minus 4, this one is prime, right? Let's pretend that had a squared on it right here. Do you see that would no longer be prime now? That would be the difference of 2 squares also now. That would be x squared minus 2 squared. So what would that factor into then, you guys? If you have x squared minus 2 squared, what would it be? I mean, look at that. What's that? X minus 2, that would be one of them. Yeah, what's the other one? Yep, the other one's x plus 2. And again, that's just using this idea over here and this, this thing. Yeah, so all I did was make those 2 little changes. I put a minus in the middle here, and I put a squared on that x, and then if that was the case, then this would be your final answer right here. Because you would have broken that down into a product of all prime factors. So all of these would be primes now. Okay, let's get back to the examples then. All right. So number 3. So number 3, if you go back to the top of the page for your notes, the first thing it says is look for a greatest common factor. Is there a greatest common factor for 10, 48, and 32? That's the largest number that divides evenly into 10, 48, and 32. That's 2, right? So you're going to have to factor. Now, so we are going to use that method, okay? It has 3 terms. So we're going to use that, 2 numbers that multiply to a times b that add up to, 2 numbers that multiply to a times c that add up to b. We're still going to use that method, but it doesn't work until we pull out the greatest common factor first. So the greatest common factor on this one is a 2. So you got to factor out a 2 first, which means you're really going to just divide 2 into all these numbers here, right? So that's going to give you a 5x squared plus a 24x plus a 16. Now, you're going to have to break this part down using that, what I underlined there inside the parentheses. You're going to have to break that down using that 2 numbers that multiply to a times c that add up to b. So for what I have inside the parentheses now, I have a is 5, b is 24, c is 16. All right, so now we're going to set this thing up. So we need 2 numbers that multiply to a times c, where the same 2 numbers add up to b. So what's a times c on this one? 5 times 16, that's positive 80. And then b on this one is positive 24. So again, where we're going to start is just numbers that 2 numbers that multiply to 80. Yep. So you could start out with 1 times 80, 2 times 40, 4 times 20, 5 times 16. What else would you get? I think that's about it, right? So Ethan already said that it was 20 times 4. So this is going to be a positive 20 and a positive 4. So those definitely multiply to 80, and then they add up to 24. Now, the other thing on this one is, we haven't done one of these in a while, so when we go to set this up now, this a right here is not 1. So remember, you have to bring that a down here, and you have to put it in here, right here also. All right? So you're going to write 5x and 5x. Now, I saw a lot of people in the homework writing 5x squared and 5x squared. No, it's not. The x is not squared. It's just 5x and 5x. And then you've got a positive 20. So you write plus 20. And then you've got a positive 4. So you write plus 4. But remember, when you use this method now, you have to divide each of these by their greatest common factor. So what's the greatest common factor in this one for 5 and 20? We need the largest number that divides evenly into 5 and 20. That's 5. So we got to divide this one by 5. Now on this one right here, it's going to stay the same because the greatest common factor for 5 and 4 is 1. So that one's not going to change. That's going to stay as 5x plus 4. And then remember, you got to divide this into both of these terms, right? So that means your final answer for that part is going to be 5 divided by 5 is 1. So it's going to be a 1x. And then 20 divided by 5 is 4, so plus 4. And then that second binomial factor stays the same. And then one last thing before you're done is you got to remember to bring this 2 down. You factored a 2 out right at the beginning. That was your greatest common factor. So that 2 needs to go in front of here, right here, like 2 times that. So that would be your final answer for that one. Now, obviously, these are going to. I'm not going to give you very many of these today. Okay, these are pretty tricky and they take quite a while. But let's keep going. So let's do. If you notice, this thing is misnumbered also. So let's do our first number 4. So there's our first number 4. So again, from the top of the page, the first thing you need to do is look at this thing and decide, is there a greatest common factor? So what is the largest number that divides evenly into 8 and 18? 8 does not divide evenly into 18. It's 2 again. So it's a 2. And then is there a x in both terms? What is the lowest power that it appears to? The second power, right? So this is going to be an x to the second. And then is there a y in both terms? Yes. What's the lowest power that appears to? Yeah, that is also a 2, right? So that is your greatest common factor right there. It's 2x squared y squared. Then when you do this greatest common factor, it's like you're doing the distributive property backwards. So now we need to fill that in. So 2 times what would give us 8? That's a 4, good. Put this like this, that's a 4. And then x squared times what would give us x to the 6th? X to the what? Some people said x to the 3rd. Some people say x to the what? No, that wouldn't do it. Now you got to remember your rules for exponents, right? If you do x to the 3rd squared, that's x to the 6th, right? But if you do x to the 3rd times x squared, that's x to the 5th. So we need x to the what? We're using this rule right here, this one. Yeah, 4th. It'd be the 4th power. Because you're doing x squared times x to the 4th. Well, you have to add the powers. That would give you x to the 6th right here. All right, and then you already have the y squared, so you're okay there. And then you would have minus. Well, then you'd have 2 times what would give you 18? 9. Good. And that's all you need on that one, right? I guess I can move this parenthesis a little bit here. Looks like that. Again, if you're not sure if you did it right, just redistribute the thing. So if you did 2x squared y squared times negative 9, that would give you negative 18 x squared y squared, which is this right here. So you know you did it correct. Okay, so let me get those out of there. Now, this is where now you got to look at what's inside here. So you have to look at this thing now, this part right here. And you have to decide, does that go further? Well, if it has 2 terms, you should look for what? Tells you up at the top of your notes. What's that? Difference of what? Yeah, difference of squares. Ethan said difference of squares. So if it's got 2 terms, you're looking for minus in the middle. That's the difference. And then you're looking for 2 squares. And so that's going to work on this one. Because this one right here, you're looking at something squared minus something squared. Well, what would you square to get 4x to the 4th? Just 2x, right? Or 2x squared, you're right. So Ethan said 2x squared. So if you take that and square it, so if you take 2x squared and square it, you get 4x to the 4th. And then what do you square to get 9? Yep, that's a 3. All right. So now your final answer on this thing, let me get this out of here. Your final answer on this thing, the difference of 2 squares, that is going to break down into, when you factor it, that's going to be 2x squared plus 3 and 2x squared minus 3. And then don't forget, you still got to bring this greatest common factor that was out in front. You have to bring that down. So that was your GCF right there. This thing. You need to bring that down in front of your answer over here. So that's going to have a 2x squared y squared in front of it. So that would be your final answer. That was pretty tricky. All right, let's go to number 5. Well, we don't have a number 5, do we? We got another number 3. So you got to do number 3 again. This one should go a little quicker. Is there a greatest common factor for 9, 3, and 2?
No.
Yeah, nothing other than 1. So this one's got 3 terms, so we're going to go right to that A times C that adds up to B. We're going to go right to that method. Okay, so in this one, we've got A is 9, B is 3, C is -2. That's probably the most common error when I've been going around helping people is like they forget to write that this C right here is actually a -2. You got to have the negative on it, otherwise it's not going to work out right. Okay, so then we're going to do the same method. So we need, for 3 terms, we need 2 numbers that multiply to A times C, where the same 2 numbers add to B. So what's A times C for this one? Yep, 9 times -2. So A times C here is going to be 9 times -2 is -18. And then B here is a +3. So then you need numbers that multiply to 18. Again, I'm not worried about the negative. You just need pairs of numbers that multiply to 18. So you could do 1 times 18. You could do 2 times 9. You could do 3 times 6. I think that's it, right? Which one of those works?
3 times 6.
Yeah, 3 times 6. So you're going to need a +6 and a -3. So this is going to be a +6 and a -3. So if you multiply those together, +6 times -3, that gives you a -18. If you add these together, +6 plus -3, you get a +3. So again, on this one, when we go to write our answer, A is not 1. So you need to bring that A down, and you need to write it right there and right there. All right, so that's going to give you a 9x and a 9x. And then right here we got a +6 and a -3. So if it's a +6, we write +6. And if it's a -3, we write a -3. Then we need to divide each of these by their greatest common factor. So what's the greatest common factor for 9 and 6?
3.
That's 3, good. And then this one, the greatest common factor is also 3, good. So divide each of those by 3. So then we get a final answer of 9 divided by 3 is 3, so we get 3x. Plus 6 divided by 3 is 2. And then we do 9x divided by 3 again, so that's 3x. And then minus 3 divided by 3 is 1. Because again, we were dividing this into each term, right? So then that's our final answer for that one. So we got to do our second number 4 and then number 5, and then I think we're done, right? Oh, there's more. Oh, is there? All right. So we got a couple more to go. Okay, so this one, our second number 4. What's the greatest common factor for 12, 48, and 48? That is 12. So you're going to factor a 12 out. Again, you're looking for that method. There's 3 terms. You're going to do the 2 numbers that multiply to A times C that add up to B. But you got to factor out the greatest common factor first. So it is a 12. And then is there a b in all three terms?
Yeah.
Yeah, what's the lowest power it appears to? The first power right there, right? So you're also going to factor out a b to the first. And then we're going to fill this thing in. So again, a quick way to do this, if you're having trouble with this, it's really to distribute a property backwards. But you can just take this term and divide it by this common factor, if you want to go that way. So that should give you a b squared. And then 12b times what would be 48b squared? That'd be a positive 4b. And then 12b times what would give you 48b? That would just be plus 4, right? So I think I did that right. Let me check that real quick. Yep. All right. So now, again, now you have to look inside of here and factor that again, if it factors. The a here is 1 for what's inside the parentheses. So for what's inside the parentheses, we have a equals 1, b equals 4, c equals 4. So again, now we need two numbers that multiply to a times c, where the same two numbers add up to b. So a times c on this one is 1 times 4. So that's just a positive 4. And then b on this one is a positive 4 also. Yep, so 2 and 2. These are all positive 2s. So positive 2 times positive 2, that's positive 4. And then positive 2 plus positive 2 is 4. Okay, so now we're going to break this thing down. So, well, a is 1 on this one. So if a is 1 and we bring it down, well, that's just going to be 1b, which is just the same thing as b. So when a is 1, we're just going to write b and b. And then we got a positive 2 and a positive 2. So it's just going to be plus 2, plus 2. And then the last thing is, don't forget to bring down that greatest common factor in front of this thing right here. So that's going to be a 12b. So that's your final answer on that one. All right. What do we got left? We got a 5, a 6, and that's it? All right, 2 more to go. All right, this one. Is there a greatest common factor for 4, 12, and 72? As a 4. So we just got to fill this thing in. So we're going to do the distributed property backwards. So 4 times what gives you 4y squared? That would be y squared. Or you can think about it, you're just dividing 4 into each of these numbers. So then this would give you plus 3y. And this will give you 72 divided by 4. That's going to be what, a negative 18? I think that's right, isn't it? All right. Same thing again. We got to break down what's inside these parentheses here. So for what's inside here. Again, that's going to be a 1 right there. So for this one, we're going to need two numbers that multiply to, well, I didn't write down what these things were. So on this one, A is 1, B is 3, C is negative 18. Okay, so then we need two numbers that multiply to A times C. A times C on this one would be 1 times negative 18, so that'd be negative 18. And then we need the same two numbers to add up to B, which is positive 3. What do you got, Ethan? What do you got? Ethan says negative 3, positive 6. That works, right? Okay, so then, again, our A is 1 on this one. So since this a is 1 right here, when I bring it down, you're just going to have 1y, which is just the same thing as y. So our final answer is going to be a y and a y. Then we have a -3 and a +6, so it's going to be -3, and we have a +6, so it's going to be +6. And then don't forget to bring that common factor of 4 down in front. And that's it for that one. So that one went a little quicker. All right, one more to go. All right, this one. So this one, is there a greatest common factor? Remember at the top of the page there, the notes say always look for a greatest common factor first. Is there a greatest common factor on number 6? Is there an x in both terms?
Yes.
Yes. What's the lowest power that it appears to?
2.
A 2. And then we're going to fill this in by doing the distributive property backwards, right? So x squared times what would give you x to the 4th? X squared. And then minus, watch this part so you get this part correct. X squared times what gives you x squared?
X.
Nope. Say it again. X squared times what would give you x squared?
0.
Negative 1.
Yeah, just -1 or just 1, right? So that's just a 1.
That took so much might out of my brain.
Yes.
I lost you.
Yeah, if you're not sure, just redistribute, right? So you would do x squared times x squared. That would give you x to the 4th, right? Then you would do x squared times -1. That would give you negative x squared. Okay. Is that one done or no? You got to look at what's inside here.
Yeah, it's prime.
If it was a plus in the middle, it would be prime. But it's not. So what this one is this is something squared minus something squared. So remember, if you're looking for the difference of two squares when there's two terms, you're looking for perfect square numbers. So you're looking for variables to even powers. And then you're looking for this number right here to be a perfect square. Perfect square numbers are 1, 4, 9, 16, 25, 36, 49, 64, 81, 100. All those numbers. Okay, so let's write the final answer for this one. So we got an x squared in front. In fact, that one right there that I just wrote down, the x squared minus 1 squared, we did that way back in the beginning of the notes here over on the side, didn't we? See that one? That is the same as this thing right here. You see it? X squared minus 1, that breaks down when you factor it, that breaks into x plus 1 times x minus 1. Yes, we already did that way back there. Yeah, so this is going to be x plus 1 times x minus 1. And then that's your final answer for that one.